Hi everyone, I'm excited to tell you about our KAI 2023 paper, Ziring. Ziring is a prototype interactive device that enables four separate hand-related interactions: gesture sensing, held object recognition, passive surface interaction, and biometric identification. Ziring makes it possible to perform all of these interactions using a single sensing modality and a single point of instrumentation on the user's finger in the form of a ring. Ziring accomplishes its function by modeling the hand as an RF antenna. The process begins with transmitting a low power, swept frequency signal from the finger, which is then reflected back to the ring. The received signal changes across a range of frequencies, and these changes are analyzed to identify the interaction. For example, a pinch pose and an open hand pose would cause different signal changes. We can interpret these changes by utilizing machine learning methods to enable interactive applications. To comprehend the properties of hand as an antenna, we conducted multiple simulations and used the outcomes to construct our systems model. Our Ziring implementation includes a portable VNA fastened to the user's wrist. The VNA reads the hand antenna's characteristic by conducting S11 measurements. The ring itself comprises of two flexible electrodes that are in contact with the user's skin and are connected to the VNA through a shielded cable. Ziring can enable four separate interaction domains. Let's start with the first one. Subtle thumb to index input. Ziring can capture changes by subtle movements of the fingers, which allow us to recognize a wide variety of subtle and ergonomic one- and two-handed gestures. These gestures include taps and swipes that may be used in on-the-go scenarios. It also supports stateful gestures like stateful pinch. Ziring can resolve continuous inputs, which can be useful for manipulating UI elements such as a scrolling menu. These subtle hand interactions can be utilized in on-the-go scenarios. For instance, in this interaction concept, a tap could initiate music playback on the smartphone, while a swipe could be utilized to adjust the volume of the music, all without requiring the user to remove the phone from their pocket. Next application domain is Ziring's capability to recognize object in the user's hand. The Ziring's field sensing technique propagates through the user's hand, allowing it to detect information about objects that the user is in contact with. Since every item has a unique RF reflectance profile, the device can distinguish which object the user is holding. This visualization shows the raw data while holding an individual object. In this demo, the system can distinguish between four distinct everyday objects, such as a soda bottle or a water bottle. This capability can be employed to enable context-aware interactions, such as automatically reserving a room when grabbing a particular door handle, or monitoring hydration levels by tracking the number of times an individual drinks from their bottle. The same sensing capability enables building passive user interfaces. These interfaces can be cut out of simple copper sheet and do not require any electronics or battery. This technique can create buttons that can be distinguished based on their distinctive shapes. This technique can also facilitate interfaces that allow for continuous input, such as 1D slider and 2D touchpad. The system can determine the location of touch on these interfaces, since each position produces a distinct signal response when touched. This makes it possible to deploy low-cost passive ad hoc interfaces in everyday settings, such as this passive slider on a coffee table that can adjust the brightness of overhead lights. Lastly, Ziring enables automatic recognition or authentication of the wearer, which can be used for privacy-focused or security-related applications. This is possible since the device can detect minute variations in reflectance properties, which arise from an individual's distinct anatomy, resulting in a unique signature for each person. In this demo, Ziring can continuously identify the user in the background while the user is wearing the ring. As an example application, a user could be logged in automatically to an app with Ziring acting as the biometric authenticator. To evaluate the performance of Ziring across different individual time periods and scenarios, we conducted a user study with 21 participants. Ziring could perform gesture recognition with up to 93% accuracy across all participants. It could distinguish between 5 buttons with about 92% accuracy and predict absolute positions on the 1D slider and 2D trackpad with less than 4 cm mean absolute error. For object recognition, the system could differentiate between 6 household objects with 95% accuracy. And finally, for identification among 14 users, Ziring could achieve 99% accuracy. These findings of the study indicate that Ziring could provide robust support for interactions. For future work, the first one is miniaturization. Currently, a prototype requires a VNA strapped to the wrist. However, future prototypes can use a chip VNA to make the ring self-contained. Second, for our current user study, we used separate machine learning models, but our initial exploration suggests that a unified model can be built which can support all applications concurrently, broadening the range of possible applications. And third, conducting a more extensive and in the wild user study would enhance our comprehension of the system's capabilities. In summary, we investigated a novel antenna topology that models the hand as a duplex antenna, facilitating human-computer interaction applications. Through sensing at a broad range of frequencies, we obtained rich data that allowed for 4 distinct hand interactions. Moreover, these findings remain consistent across users and over time. For more details and future work, please refer to our paper. Thank you for listening to this, and I'll be happy to answer any questions or suggestions you may have on this project. Please feel free to reach out to us. Thank you so much.